Hi, I'm Year 11. We're moving on now to section 10D in the textbook. And we're going to have a look at two theorems, the factor theorem and the remainder theorem. These are going to be two really useful theorems to use in the polynomial topic, as it allows us to work out, I guess, remainders or if something is a factor of a polynomial without actually having to do the long division. Because sometimes when we do the long division, it takes a long time and there's a lot of room for error, basically. Okay, so if we have a look at what the remainder theorem says, and I might just highlight that for us. The remainder theorem says when f of x, which is a polynomial, is divided by x minus a, the remainder is going to be f of a. So let's have a look at what that actually means with an example. So when the polynomial f of x is divided by some other function, x minus a, the remainder is f of a. So example here is saying, find the remainder when x cubed plus x squared plus x plus 1 is divided by x minus 2. So this is our polynomial, f of x, or I actually like to call it p of x. So I'm going to change this one to a p, just because p for polynomial makes a lot more sense, but it is a function, so f is okay. So we're going to find the remainder. So let's use the rule. So it says when p of x is divided by x minus a, so here's our p of x, here's our x minus a, the remainder is going to be f of a, or p of a. So note that it's like working with our zeros. We're saying x minus a is equal to 0, so we're looking at x is equal to a. In this case, we're going to have a look at x is equal to 2. So p of 2 will give us our remainder. So that's going to be 2 cubed, and I'll pop it straight into my polynomial, plus 2 squared, plus 2, plus 1. 2 cubed, 2 2s are 4, 4 2s are 8, plus 4, plus 2, plus 1, which is 8, 9, 10, 11, 12, 13, 14, 15. So our remainder is going to be 15. I'll just write that in there. Now, since we're only new to polynomials, and I like to make sure that we always know what we always want to know what we're doing. So I'm actually going to check this remainder out by doing long division. So let's go and do that. Let's go and divide x minus 2 into x cubed plus x squared plus x plus 1, and see if we actually do get 15 as our remainder. So if you want to pause the video and have a go at that now, I'll do it through the video, but you can check and it'll be good practice for you. Okay, so how many times does x go into x squared? We want to have, into x cubed, we want to have x squared. X squared times x is x cubed minus 2x squared. Let's take them away. X cubed minus x cubed is 0. 1x squared minus 2x squared is 3x squared plus x plus 1. Now, how many times does x go into 3x squared? It's going to be 3x, because 3x times x is 3x squared. And we want to get rid of these terms. 3x times minus 2 is minus 6x. So if we do a big subtraction there, 3x squared minus 3x squared is 0. 1x minus 6x is 1 plus 6, which is 7x plus 1. How many times does x go into 7x? That's going to be 7 times. Let's multiply out by the 7. 7 times x is 7x. 7 times minus 2 is minus 14. Let's do a subtraction. 7x minus 7x is 0. 1 minus 14, which is 1 plus 14, which is 15, which is our remainder, which is what we've gotten over there. So, as I noted at the start, this remainder theorem is really good because we didn't need to do long division to find our remainder. We got 15 in one line here. We still got 15 over here. So there's the option to do that. But remember, in our HSC and in our exams, we're looking at finding shortcuts for time. This way is a lot quicker and there's a lot less room for error. I could have many steps here where I could make a lot of errors. And over here, straight through into our calculator, I could have popped that in, or doing it in my head, less room for mistakes. So let's look at the remainder theorem again. When a polynomial is divided by some other function, the remainder is f of, in this case, a. Let's have a look at the second one. Okay, example. Find a if x cubed plus ax squared plus x minus 4 divided by x plus 1 is going to be equal to our quotient q of x minus 8. Now, when you first look at this second example, it actually looks really tricky. But I want you to have a think about how that would relate back to our previous example. Here we said we had to find the remainder when our polynomial was divided by something, and we would have had some quotient minus or plus a remainder. This is exactly what this example down here is saying. We have a polynomial and it is divided by this function here. It gives us some quotient and a remainder of minus 8. So we have basically got the same question as above, and we're just going to play around with it a little bit to get our solution. So I'm going to write in here that our remainder, well, let's just call it, instead of the word remainder, let's call it r of x. Let's be a little bit more mathematical. Our remainder is r, and it's minus 8. And we know from our question above in our rule, when we're dividing by something, we're using our rule. So p of 2 came from our x minus 2, gave us our remainder. So if this is my polynomial, p of x, if I'm going to find out what p of minus 1 is, because I know I'm dividing by x plus 1, so x plus 1 equals 0. So x is equal to minus 1. That's my minus 1 in there. If I pop that into my polynomial, I'm going to end up with a remainder of minus 8. So let's pop that in there. Minus 1 cubed into here, plus a lots of minus 1 squared, plus minus 1, which I'll just leave as minus 1, minus 4 is going to equal my minus 8. Let's fix that up a little bit more. Minus 1 cubed. If you're not familiar with this, pop in your calculator, but minus 1 times minus 1 is 1, times another minus 1 is minus 1. Minus 1 squared is 1, so it's going to be 1 times a, which is a. We've got a minus 1, minus 4 is equal to minus 8. Okay, minus 1, minus another one is minus 2, minus another minus 4 is minus 6. So a minus 6 is equal to minus 8. So a, if we add 6 to both sides, is going to be minus 8 plus 6, and I've added plus 6 over here. So a is going to be equal to minus 2. Okay. Let's double check it with long division. A little bit of practice. You don't need to double check it in your examination situations, but we're new to this, so let's see if it works. So we've said a is minus 2, so let's pop our minus 2 into our polynomial. We'll end up with x cubed minus 2x squared minus 2x, oops, sorry, not minus 2x, minus x, because there was only one a in there. Let's get my pen fixed up there. Plus x minus 4. So the only place I popped an a in is in there. I'm going to divide that by my x plus 1, and we'll work out our solution. Just pop that remainder up there, and we'll go and see if we get a minus 8 as our remainder. So how many times is x going to x cubed? It's going to be x squared. Just zoom in there a little bit. Multiplying back out, I'm going to get x cubed plus x squared, and we're going to do a subtraction. X cubed minus x cubed is 0. Minus 2x squared minus x squared is minus 3x squared. And my plus x minus 4 have nothing to subtract from, so they stay there. Now, looking at how many times x goes into minus 3x squared, we're going to end up with minus 3x. Multiplying out, we end up with minus 3x times x is minus 3x squared. Minus 3x times 1 is minus 3x. Let's subtract those lines again. Minus 3x squared minus 3x squared is minus 3x squared plus 3x squared. So yes, that goes to 0. I have x minus 3x, which is x plus 3x, which is 4x minus 4. Now we are going to multiply by, how many times does x go into 4x? It goes 4. 4 times x is 4x. 4 times 1 is 4, or positive 4, and we're going to do a subtraction there. And I think we're just about there. 4x minus 4x is 0, minus 4 is minus 8, and that is our remainder. Is that the same as what we had to start with? Let's go and check. It is. There's our minus 8. So we've confirmed it, but now that we're kind of hopefully getting the hang of it a little bit, we won't need to confirm via our long division. Our rule tells us that, when a polynomial is divided by some other function, for example, x minus a, the remainder is f of a. So we need to memorize that. That is something that you're not going to get given to you in your HSC examination, but you'll need to memorize it. Okay, let's have a look at another one. Another example. Find the remainder when x cubed plus 2x squared minus 6x plus 4 is divided by x minus 1 squared. Okay, so this one's going to take a little bit more of just thinking about it, and it's something I actually haven't explained so far. So for this example, we're finding the remainder when this polynomial, the cubic, is divided by x minus 1 all squared. Now, we can't use our theorem that we used before for this one, because what I haven't actually, I guess, shown you in here is with this theorem, let's get rid of that little p of x there. When a polynomial is divided by a function that is linear, the thing that it's being divided by, it needs to be a linear function, which we've had in our previous questions. We don't have this in this one here. So at this point, we don't have enough information for us to do anything other than do it the long division way, okay? So find the remainder when a cubic is divided by, this is going to be a quadratic. So let's expand this one out. What do we get when we expand that? We square the first. Our middle term is 2 times the first times the second, which is minus 2x. And we square the last term. So for now, I just want to have a look at this as a polynomial long division. So let's pop that in as a long division. We'll have a look at some harder questions and look at some different variations, but for now we're just going to have a look at it like this. So pause the video if you want to go ahead and have a go at doing this long division yourself and see if you get the same answer as me, but I will go through with the video. Okay, how many times does x squared go into x cubed? It's going to be x. X times x squared is x cubed minus 2x squared plus x. We're going to subtract each of those terms. So x cubed minus x cubed is 0. 2x squared minus 2x squared is 2x squared plus 2x squared, which is 4x squared. Minus 6x minus x is minus 7x, and our plus 4 stays there. Okay, now we're having a look at this polynomial and our divisor. So x squared goes into 4x squared 4 times. Now we multiply it through by the 4. 4 times x squared is 4x squared. 4 times minus 2x is minus 8x. And 4 times 1 is 4. We're going to subtract each of those terms. 4x squared minus 4x squared is 0, so that's good. Minus x minus minus 8, which is minus 7x plus 8x, which is plus 1x. And 4x minus 4 is 0. So in this case, the remainder is going to be 1x. Okay, so that was a brief look at the remainder theorem. Now we're going to have a look at the factor theorem, which basically is the same as the remainder theorem. But if a function is a factor of a polynomial, then we're not going to have any remainder. And that's what our factor theorem is telling us. If x minus a is a factor of a polynomial, it is that factor if and only if p of a is 0. So that basically means we have no remainder. And I'm going to jot that down in there, and I want you to pop that in there. Okay? So I'll say this means there is no remainder. That means it goes and factorizes perfectly in. There's no terms left over. So we can check if some function is a factor of a polynomial by popping in the, in this case, x minus a. If we're checking that's a factor, we're going to pop a in to our polynomial. If that is equal to 0, then we know there's no remainder, and yet there is a factor. So let's test our first example. It says to show that x minus 1 is a factor of x cubed plus 4x squared plus x minus 6, and hence factorize. Okay, so let's do step 1. Let's show it's a factor. So that's my first bit. I'm going to show it is a factor. Okay, and we're going to do that using our factor theorem. So if it's a factor, then p of 1 should equal 0. So let's show that it does. P of 1 is equal to, we're going to pop our 1 in here where there is an x, 1 cubed plus 4 times 1 squared plus 1 minus 6. 1 cubed is 1 plus 4 times 1 squared is 4 plus 1 minus 6. 1 plus 4 is 5. 5 plus 1 is 6. 6 minus 6 is 0. We can say, therefore, since p of 1 is 0, then x minus 1 is a factor. I would like you to get into the hang of writing a sentence at the end like I've done. I've shown it, then you need to state the rule at the bottom. If you just leave it up to here, I'm not happy enough with that. So I'm looking for this bit as well. So I've shown it as a factor, therefore there's no remainders. So if I was now to divide x minus 1 into my cubic, I will find what the other factors are going to be. Okay, so let's use some long division. If I'm not going to do it down the bottom, I'm going to try it at the side, so I don't think there's going to be enough room. So I'm going to divide x minus 1 into x cubed plus 4x squared plus x minus 6. And in doing so, we know this is a factor, so we're going to get no remainder. So our quotient that we get at the top should be a quadratic, and we should be able to factorize that as well. Okay, see what we can do with that. So how many times does x go into x cubed? It goes x squared times. X squared times x is x cubed. X squared times minus 1 is minus x squared. We are now going to do a subtraction of each of those terms. X cubed minus x cubed is 0. 4x squared minus x squared is 4x squared plus x squared, which is 5x squared. These pair have nothing to subtract, so they're still going to go in as themselves. Next step. How many times does x go into 5x squared? It goes 5x, because 5x times x is 5x squared. 5x times minus 1 is minus 5x. Again, we're going to do a subtraction. 5x squared minus 5x squared is 0. X minus 5x is x plus 5x, which is 6x. Minus 6 goes down there because there's no term below it. Okay, just put the plus in there. How many times does x go into 6x? It goes in 6 times. 6 times x is 6x. 6 times minus 1 is minus 6. We're going to do a subtraction. 6x minus 6x is 0. Minus 6 minus 6 is minus 6 plus 6, which is 0. No remainder, which is what we want. Okay, So we are fully factorizing our polynomial. This cubic is equal to this linear out the front multiplied by this quadratic. And I'm going to write that down here. So we can say that p of x, which is equal to x cubed plus 4x squared plus x minus 6 is equal to x minus 1 multiplied by, we have a look at my quadratic at the top, I ended up with x squared plus 5x plus 6 and no remainder, but that is equal to x minus 1. Can we factorize these two brackets any further? I think we can. We can add to 5. We can multiply to 6. We've got 3 and 2 plus 3 plus 2. So I have now fully factorized my cubic, and there's our solution. Now, remember I said, all through our accelerated year 10 class, I've said that we've not had any rule anymore that we could use to factorize a cubic. Well, now we do. And we're going to have a look at some other ways now that we can also work out some factors of a cubic without actually being given a factor already. So we've got one more example to go down here, and then I'm going to do some in the OneNote to help us through. So we'll look at the next example here, and then we'll go and do the stuff in the OneNote. Okay, so our next example says if x plus 3 and x plus 2 are both factors of our polynomial, find a and b. So we can use our factor rule, okay, that if each of these are a factor, then if I substitute in minus 3 and then I substitute in minus 2, each of those substitutions should give me 0 because they're both factors. If I do that twice, I'm probably going to come up with a simultaneous equation to solve. So let's see where we go. So I know that x plus 3 is a factor. So p of minus 3 is going to be 0. And I know that x plus 2 is a factor. So p of minus 2 is also going to be 0. That's what I know. Let's use that information now in this polynomial. So p of minus 3 is going to be minus 3 cubed plus 2 times minus 3 squared minus 3x plus b. That equals 0. If you would like to pause and see if you can have a go at this by yourself, I think that would be a really good idea, but I'll keep going on the video. P of minus 2 will give me minus 2 cubed plus 2 lots of minus 2 squared minus 2a, so I've just popped it in there for the x, plus b, and that will also equal 0. Let's neaten these guys up. Our first one, minus 3 cubed. 3 cubed is 27. The minus cubed is a minus, so minus 27. 3 squared is 9. 9 twos are 18. That minus there is squared and becomes a plus. Here we've got, oops, I've made a mistake here. That shouldn't be minus 3x, that should be minus 3a. Sorry, minus 3a plus b equals 0. Let's neaten that up. Minus 27 plus 18 is minus 9. And we've still got minus 3a plus b is 0. I'm going to add 9 to both sides, so I end up with minus 3a plus b is equal to 9. There's my first equation that I've got from here. Okay, let's do our next one. Minus 2 cubed is minus 8. 2 cubed here again, basically, because it's 2 squared times another 2. 2 twos are 4, 4 twos are 8. That's minus is a positive, so it becomes plus 8. We've got minus 2a plus b equals 0. Minus 8 plus 8 is 0, so I end up with minus 2a plus b equals 0, and that's our second equation. So we've basically ended up with two simultaneous equations here, which we need to solve. we could just add those two together. Might be the easiest way. I'll write this one underneath here. Minus 2a plus b is equal to 0. And let's take them away. Let's go 1, take away 2, because then that will eliminate our b's. So minus 3a minus minus 2a is minus 3a plus 2a, which is minus a, is going to equal us, the b's disappear, 9. So a is minus 9. Let's find us a b. You can use either equation to find your b. I might just use the second one here to find my b. So I've got minus 2 times minus 9 plus b is 0. Minus 2 times minus 9 is 18. Plus b is 0. So b is minus 18. So there are two solutions. Hopefully those are right. You guys have a go. See if you get the same solution as me. Now they're the questions that are in our notes. I'm going to jump over to the OneNote and we're going to have a look at some other questions that involve the factor and the remainder theorem. So I'll meet you over there.